Okay, continuing on with differentiation, we need to learn how to take the derivative of certain functions that aren't defined implicitly. So first of all, what does it mean to be implicit versus explicit? An explicit function is where I have a function that's y equals some function of x. So that's explicit. So for example, y equals x squared minus 2, or y equals x e to the x squared, something like that. It's where I have y by itself. So taking the derivative of these, we didn't have that much trouble with. So for the first one, I would say dy dx is 2x. On the second one, I would use the product rule, and I would get e to the x squared plus x e to the x squared times 2x using the chain rule. So whenever we had explicit functions, all we did was take the derivative with respect to x on both sides, and that's how we found the derivative. But now what about implicit? So implicit is where I don't have y by itself. So y isn't by itself. So for example, x squared plus y squared equals 4. That would be an implicit function because y is not by itself. Something like 2x minus y plus 4 equals x. Also not implicit. Now you could make this one explicit. Sorry, this is not explicit. You could make it explicit though by solving for y. But in its current form, this is implicit. This is not explicit. So what this section that we're doing is how to take the derivative of implicit functions. So this is section 3.10, and it's implicit differentiation. And all the differentiation that we've done of explicit functions, where we had y equal to something where y is by itself, and we just took the derivative. But now we're going to have problems where y is not necessarily by itself, but we still need to find the derivative. So let's go over a few things first before we kind of jump into implicit differentiation. And let's talk about what dy dx actually means. So dy, this means that y is the function. That's what the y means. Dx says x is the variable. Now it doesn't have to be y and x. I could do a bunch of different functions, but I think it's important to know what this notation really means. So for example, consider the function f of x is x plus y. Now what is df dx? This means take the derivative of this function where x is considered the variable. So let's go through. What's the derivative of x with respect to x? That's just 1. What's the derivative of y with respect to x? Well, that's exactly what it is. It's dy dx. We don't know if y is a function or a constant, so what we would write is dy dx. This just said the derivative of y with respect to x. Okay, let's try the derivative of f with respect to y. So now y is my variable. X could be a constant, x could be a function, we don't know. So what's the derivative of x with respect to y? Well, we don't know, so we would just say dx dy. And now what's the derivative of y with respect to y? That would just be 1. Okay, how about the derivative of f with respect to some other variable, w? So here w is the variable. We don't know if x and y are variables or functions. So let's start with x. What's the derivative of x with respect to w? That would be dx dw. And then the derivative of y with respect to w, dy dw. So again, whatever is on the bottom tells you the variable. Now if you're taking the derivative of, let's say, y, where x is the variable, then it's just dy dx. So maybe let's do one more of these. Let's say that f, I guess I should say x comma y. Let's say that it's x squared minus y. And I want to know what's df dx. So I'm saying what's the derivative of this function, and let's treat x like the variable. Well, the derivative of x squared with respect to x is just 2x. Now the derivative of y with respect to x, well, I don't know if y is a function or just a constant, so we'll say minus dy dx. Let's find the derivative with respect to y. So this is a little bit tricky now, because what's the derivative of x squared with respect to y? Well, now that's a chain. The first part of that is the function x, because x is not our variable anymore, our variable is y. The second one is x squared. So the derivative of x squared with respect to y is going to be 2x dx dy. So 2x came from this second step, then the dx dy came from the first step. So we've done the derivative of x squared. Now what about the derivative of minus y with respect to y? So y is your variable, so it would just be minus 1. Okay, lastly, let's do df dp. Let's say that p is now the variable. Again, we're going to treat x and y like they're functions, because our variable here is p. Neither one of these are variables now. So I need the derivative of x squared with respect to p. So x is a function, which means I have 2 steps. So the derivative of x squared would be 2x times dx dp. Now I'm going to subtract the derivative of y with respect to p, so that's just dy dp. So whatever variable is on the bottom here, that's what you treat as the variable. Everything else we're going to treat as a function, because we don't know if it's a function or a constant. So treat everything else like a function and use the chain rule when we're doing implicit differentiation. Okay, so let's write that down in words. We're going to have d something, we don't know what that something is, over d, and let's say this is maybe an alpha. That's what we're trying to find. So what you're going to do is you're going to treat alpha as the variable. You're going to treat everything else, so treat all other letters as functions, and you're going to use the chain rule. This is how we do implicit differentiation. These are the steps to take. So we're going to be trying to find d something, d alpha. This something depends on your function. It could be f, could be y, whatever. It'll depend on the problem. We're going to treat alpha as the variable because that's what's on the bottom. Everything else is a function, and we're going to use the chain rule. So that is implicit differentiation. So let's do some examples of this. Let's consider x squared plus y squared equals 9, and let's find dy dx. Dy dx is definitely going to be the most common implicit differentiation you're going to do. So if you have a problem that's in terms of x squared, or x and y, and it says find the derivative, dy dx is what you're looking for. So if it doesn't specify what to look for, it's dy dx. So in this problem, x is the variable, and the only other letter here is y, so y is a function. Okay, so let's take the derivative. This is a sum on the left-hand side. So what's the derivative of x squared where x is the variable? That's 2x. Now what's the derivative of y squared where y is a function? Well, let's see, my first one would be y, then I'm going to square it. So start with the second one here. The derivative of y squared is 2y. Now the derivative of y, remember this is with respect to x, would be dy dx. And then what's the derivative of 9 with respect to x? Well, 9 is just a constant, so I just get 0. Now what I'm going to do is I'm going to solve for dy dx. So I'll get 2y dy dx is negative 2x. Divide both sides by 2y, so dy dx is negative x over y. So using implicit differentiation, I was able to find dy dx. Again, what we do is treat whatever's on the bottom as the variable, everything else is going to be a function, and then use your chain rule. Let's try another example here. Let's let the function, or the curve, be given by negative x cubed plus 3x plus 3y squared. Let's say that's equal to 9. And let's find the slope of the tangent line at the point 0, square root of 3. Okay, so we're trying to find the slope of a tangent line. Go back to what we've been doing before. Slope of a tangent line comes from the derivative. So whenever we were trying to find the slope of a tangent line before, we would find f prime, plug in our x value. Well, here, y is not by itself, so it's slightly different. So what we're going to do is first find dy dx. Right, that's our derivative, dy dx. Remember I told you, anytime it's x's and y's and they don't specify what to find, dy dx is your go-to. Then I'm going to plug in x equals 0, y is the square root of 3. That's how I'm going to find the slope of the tangent line. If you recall, what did we do before? We would find f prime, and then we would plug in for x. It's the same idea, only now we have to use implicit differentiation. So let's find dy dx. This means that x is the variable, y is a function. So what's the derivative of x cubed with respect to x? That's negative 3x squared. What's the derivative of 3x with respect to x? Just 3. Now I got to worry about what's the derivative of 3y squared with respect to x. So let's see. The inside function there is y, because y is a function. Second one is 3y squared. So my derivative would be 6y times dy dx, because the derivative of y is dy dx, and the derivative of 9 is 0. And now we're just going to solve for dy dx. So I'll get 6y dy dx is 3x squared minus 3. So dy dx is 3x squared minus 3 over 6y. Okay, so we found dy dx. What was the next step? We need to plug in x equals 0, y equals square root of 3. So dy dx, evaluated at the point 0, square root of 3, is going to be 3 times 0 squared minus 3 over 6 times the square root of 3. So that's minus 3 over 6 square root of 3, which is what? Minus 1 over 2 square root of 3. So there's the slope of my tangent line at that point. So again, finding the slope of the tangent line at a point, find the derivative, plug in a point. That's never going to change. The only difference here is that to find the derivative I had to use implicit differentiation, or just the chain rule, is really all it is. Okay, so let's try one more of these. Get a new page for this. let's find the equation of the tangent line. To the curve, x cosine y equals 1/2 x, where x equals 1. Okay, so I'm finding the equation of a tangent line. What is your answer going to look like? Well, a tangent line is y equals mx plus b. First thing we got to find is m. Second thing we got to find is b. Let's find m first. So when we were doing this before, what do we do to find m? We found our derivative, plugged in a point. It's exactly what we're going to do here. So we're going to find dy dx, then we're going to plug in. Nothing's changed, only how we find dy dx is probably going to be a little bit more difficult. So my function is x cosine y equals 1/2 x. I'm trying to find the derivative with respect to x, so I'm going to take the derivative of the left and the derivative of the right. Well, let's see, the derivative of the left is just 1/2. That one's not very hard. Now what about the derivative of the right? Well, this is x times cosine of y, so I'm going to have to use a product rule. So the derivative of x with respect to x is just 1. Now the derivative of cosine y, we're going to have to treat y as a function and use our chain rule. Oops. So the derivative of cosine is negative sine times dy dx. So the derivative on the left-hand side is going to be u prime v, so that's cosine y times 1, plus u v prime, so what is that? Negative sine y times x times dy dx. Okay, so let's continue this down here. I gotta solve for dy dx, so I'll get negative x sine y. All I did was move that x in front of the sine. Dy dx is 1/2 minus cosine y. So dy dx is 1/2 minus cosine y over negative x sine y. So there's my derivative. So I found my derivative. Go back to what we're trying to do here. Trying to plug in my point. Well, the thing is, I only know x. If I'm going to find the derivative at the point, I need to know what y is because I need to plug in for y. So we need to find y before we plug in. Well, how am I going to find y? Go back to your original function. I know that x cosine y is 1/2 x. Plug in 1 for x because that's what the problem said. So cosine y equals 1/2. Look at your unit circle here. That means y is pi over 3. So the point that we're using is 1 pi over 3. So now plug that into my derivative. So I'll get 1/2 minus cosine pi over 3 over negative negative 1 sine of pi over 3. Okay, so cosine of pi over 3, that's 1/2, so I'll get 1/2 minus 1/2 over stuff, well that's just 0. So what does that mean? That means that m is 0. Now I just want to emphasize what we just did. We were finding the slope of the tangent line, so I took the derivative and plugged in my point. Now the problem that we ran into is what was the y value, so we went back to our original function and found out what y was. So we plugged that in, got m. Second, we need to find b. We're going to use the point that we already did, 1 pi over 3. From part 1, I know that y is 0x plus b. plug in this point, so I'll get pi over 3 is 0 times 1 plus b, so b is pi over 3. Therefore, the equation of my tangent line is 0 times x, which is just 0, plus pi over 3. So y equals pi over 3. So what the takeaway from all this is that finding the slope of a tangent line, finding the equation of tangent lines, that hasn't changed. The only thing that's changed is that you might have to find the slope a little bit differently using implicit differentiation. Let's see, I want to do maybe one more. Let's consider the curve negative r squared plus s equals 4. And let's find dr ds. So the reason I want to do this is I want to see what happens when x and y are not your variables when I have something different. So let's see, I'm treating r as a function, s is your variable. So start with the left-hand side here. R is a function, so to find the derivative of negative r squared, I gotta use the chain rule. Inside function is r, outside function, negative r squared. So the derivative will be negative 2r times dr ds. Now what's the derivative of s with respect to s? So s is your variable, that's just 1. Now the derivative of 4 with respect to s, 4 is a constant, so just 0. And now I could solve for dr ds. So dr ds will be, what, negative 1 divided by negative 2r, so 1 over 2r. So just remember, what is up top? That tells you the function. What's on bottom? That's your variable. Anything else that's not listed, treat it as a function. So, implicit differentiation, if you do that and use your chain rule, you'll be perfectly fine.